Hello everyone, this is Kaiming, and today we're going to do a short explanation of dropout, which is a widely used technique in deep learning to reduce overfitting. So first, let's introduce some background. Dropout is proposed by Geoffrey Hinton and adopted by the famous AlexNet. AlexNet is the first CNN-based method that achieved huge success in the ImageNet challenge in 2012. Dropout is a regularization technique to reduce overfitting in deep learning. So intuitively, activations in neural networks are dropped out, as suggested by its name. Okay, now let's talk about how to implement dropout. So dropout behaves differently in training and in inference. During training, dropout randomly sets any certain activation to 0 with a probability p between 0 and 1. So to the left, we have a 4 times 4 feature map after a p equals 0.2 dropout. So as you can see, roughly 20% of activations are set to 0, which are those neurons that is with red crosses on it. So after we set some certain neurons or activations to 0, there is one thing to do, which is to keep the activation mean roughly the same. So to do so, all activations are multiplied by 1 over 1 minus p after the set to 0 step. So that after this step, you'll have the average of the feature map roughly the same before and after the dropout step. During inference, dropout is disabled, which means that the set to 0 step and also the multiplication will not happen. So the more important problem is how do we understand dropout? So in dropout, activations are set to 0 so that these neurons do not contribute to the forward or the backward pass. Dropouts force neural networks to not rely on any certain neurons too much, and also push them to learn more robust features, since that any activations might be randomly set to 0. So to the left, we have an illustration of dropouts in different forward passes. As you can see, in each pass, different activations or different neurons are dropped out. So this mode or this phenomenon will force the neural networks to learn to not rely on any certain neurons too much, which should enable the network to be more robust. So next, we're going to talk about some limitations of dropout and how do we deal with them. In image tasks, adjacent features are often highly correlated. What does that mean? So as we all know, pixels usually share similar features with its neighbors. Like if we have a pixel at location 2, 2 with color yellow, its neighbors are very likely to be yellow. So this phenomenon means that we can simply drop any discrete pixels because this information dropped out will still be maintained by its neighbors. So that's why drop block is proposed. So drop block proposes to drop an entire block of features instead of incontiguous activations, like this illustration to the right. So to the left, we have the traditional dropout, which just randomly drop any activations. So to the right, we have drop block, which drops an entire block of a certain size. This will break the high correlation of adjacent features. So another problem about dropout is its disharmony with batch normalization. So batch normalization is a deep learning technique for accelerating the convergence of training and also it has some effect of reducing overfitting. But in the original batch normalization paper, the authors found that batch normalization could be incompatible when put together with Dropout. So what is actually happening here? The problem is that the variance of the feature output by Dropout shifts between training and inference mode. So to the right, we have a table. There are two columns. The first column is the mean and variance under the training mode of the features output by Dropout. And the column to the right is the same statistics under inference mode. So due to the multiplication step, we have roughly the same mean under the training and inference mode. But because of the set to zero step, we actually have larger variance during training mode than the inference mode. So this variance shift caused the variance statistics calculated by batch normalization during training mode become inaccurate because the variance won't be the same during inference mode. That's what makes batch normalization incompatible with Dropout. But there is an easy fix. We can simply apply Dropout after the batch normalization. So that's the end for this Dropout explanation video, and I put all references here. So thank you very much, and I wish you a pleasant day.